Close your eyes for a moment and imagine waking up one day to a world that looks permanently fogged, like you're staring through a dirty window you can never clean. Because for millions of people worldwide, that's not imagination, that's cataracts. And the most unsettling part is that this loss of vision doesn't happen overnight. It happens silently, molecule by molecule, through a process driven by oxidative stress. Inside your eyes sits the lens, a clear living structure made almost entirely of tightly packed proteins, arranged with such precision that light can pass through without scattering. And the only reason you see sharply right now is because those proteins remain perfectly ordered. But unlike most tissues in your body, the lens cannot shed damaged cells or regenerate itself. So when damage accumulates, it stays there for life. Every time light enters your eye, it delivers energy, and while light allows vision, it also carries a hidden cost because ultraviolet rays from the sun and high-energy blue light from screens generate reactive oxygen species, unstable molecules that aggressively steal electrons from healthy cells. And when these free radicals strike lens proteins, they cause them to unfold, clump together, and scatter light, which is the very definition of a cataract. Research has shown that by the age of 40, measurable oxidative damage is already present in the human lens, long before symptoms appear, and by age 60, the antioxidant defense systems in the eye decline dramatically, leaving the lens exposed to decades of accumulated molecular injury that no surgery-free solution can reverse. What makes this even more alarming is that the lens exists in one of the most oxygen-sensitive environments in the body because it relies on a delicate balance, enough oxygen to survive, but not so much that oxidation accelerates, and when that balance is disrupted by aging, smoking, poor diet, diabetes, or chronic inflammation, oxidative stress increases exponentially. Smoking alone has been shown to double the risk of cataracts, not because smoke touches the eye, but because it floods the bloodstream with oxidants that reach the lens within minutes, while high blood sugar creates glycation end products that weaken lens proteins and make them even more vulnerable to oxidative attack. Sunlight exposure compounds the problem further, and large population studies have found that people living in high UV regions experience significantly higher cataract rates, especially when eye protection is inconsistent, because UV radiation penetrates the eye and generates free radicals directly inside the lens, triggering damage that builds year after year. What's most disturbing is that cataracts are not rare or unusual. They are the leading cause of blindness worldwide, responsible for nearly half of all cases of vision loss. And while surgery can restore sight, it does nothing to address the biological processes that cause the damage in the first place. At the center of this process is oxidative stress, a state where free radicals overwhelm the body's antioxidant defenses. And while your eyes are equipped with protective compounds like glutathione, vitamin C, and carotenoids, these defenses decline with age. And once depleted, the lens becomes defenseless against oxidative chaos. Studies analyzing cataract lenses have repeatedly found elevated levels of oxidized proteins, lipid peroxidation markers, and DNA damage, confirming that cataracts are not just a mechanical clouding of the lens, but the visible outcome of years of unchecked oxidative injury. Even more striking is the fact that people with lower dietary antioxidant intake consistently show higher cataract prevalence, suggesting that lifestyle does not just influence vision quality, it influences whether the lens can survive decades of environmental stress intact. This means cataracts are not simply a consequence of getting older, they are the biological record of how much oxidative stress the eye has endured, how often it was protected, and how well it was nourished during that time. When researchers compare populations with high intake of antioxidant-rich foods to those consuming highly processed diets, the differences in cataract risk are not subtle. They are statistically significant, reinforcing the idea that the lens reflects long-term nutritional and metabolic health. What keeps this from being common knowledge is that cataracts progress slowly, often over decades, so the damage feels invisible until it suddenly interferes with daily life, blurring faces, dulling colors, and making nighttime driving dangerous long after the molecular damage is already done. Oxidative stress doesn't announce itself, it whispers, quietly degrading proteins, slowly altering lens transparency, and patiently waiting until enough damage accumulates that vision can no longer compensate. And by the time symptoms appear, The lens has already lost its ability to protect itself because, unlike skin or muscle, the lens does not replace damaged proteins, meaning prevention is the only real defense. This is why scientists increasingly view cataracts as a disease of cumulative oxidative stress rather than an unavoidable consequence of aging, and why research continues to focus on reducing free radical exposure and strengthening antioxidant defenses long before vision loss begins. Every blink exposes the eye to light, every breath exposes it to oxygen, and every metabolic reaction produces free radicals, meaning oxidative stress is not optional, it is constant, and the only variable is whether the body can neutralize it fast enough. When that balance fails, clarity turns to cloudiness, transparency turns to opacity, and the world slowly loses its sharpness, not because the eye stopped seeing, but because the lens could no longer stay clear under the relentless pressure of oxidative damage. And that reality forces a sobering conclusion. Cataracts are not a sudden failure of the eye. They are a slow, preventable erosion of clarity driven by oxidative stress, accumulating quietly until the moment vision finally gives way. Long before vision begins to fade, long before the world softens at the edges or colors lose their intensity, something remarkable is already happening deep inside the eye, because certain nutrients from food don't just circulate through the bloodstream. They are actively pulled into the eye, selectively concentrated, and locked into place as a final line of defense against blindness. Among thousands of compounds we consume, only two carotenoids are deliberately accumulated in the human retina and lens in significant amounts: lutein and zeaxanthin. And this alone tells scientists something extraordinary, because the body does not waste energy transporting compounds unless they serve a critical survival function. These pigments are found in their highest concentrations in dark leafy greens like kale and spinach, foods that humans have eaten for millennia, long before modern medicine, surgery, or eye drops existed, and their presence in the eye is not accidental. It is evolutionary design responding to constant exposure to light. At the center of vision sits the macula, the most metabolically active tissue in the eye, responsible for sharp detail, color perception, and contrast. And this region is bombarded by intense light energy every waking moment, making it one of the most oxidative environments in the entire human body. Lutein and zeaxanthin physically embed themselves into this tissue, forming what researchers call the macular pigment, a yellowish filter that absorbs high-energy blue light before it can damage delicate cells, reducing oxidative stress at the exact point where vision is most vulnerable. Multiple imaging studies show that people with higher dietary intake of leafy greens have significantly denser macular pigment, and this density directly correlates with reduced markers of oxidative damage in the eye, essentially meaning the food you eat determines how well your eyes can shield themselves from light-induced injury. But the protection does not stop at the retina, because these same carotenoids are also found in the lens, the transparent structure responsible for focusing light, where they act as antioxidants, neutralizing free radicals before they can damage lens proteins and initiate cataract formation. When scientists analyze cataract-affected lenses, they consistently find lower levels of lutein and zeaxanthin compared to healthy lenses, a finding that appears again and again across different populations, diets, and age groups, reinforcing the link between carotenoid depletion and lens clouding. Large-scale observational studies reveal that individuals with the highest intake of lutein and zeaxanthin have a significantly reduced risk of developing age-related cataracts, in some cases by more than 20%. A striking difference for a disease often considered inevitable. What makes this even more compelling is that these compounds are not generic antioxidants floating randomly through the body. They are structurally designed to interact with light, capable of quenching singlet oxygen and dissipating excess energy as harmless heat, preventing molecular damage at its source. In other words, leafy greens do not just nourish the eye, they actively intercept destructive forces before vision is compromised, performing a role that no supplement or medication can fully replicate once damage is already done. Yet despite their importance, most modern diets are critically deficient in these carotenoids, with research showing that average intake levels fall far below what is associated with protective macular pigment density, especially in populations consuming highly processed foods. This deficiency is not immediately noticeable because the eye draws from stored reserves, but over time, as oxidative stress accumulates and intake remains low, those reserves diminish, leaving the lens and retina exposed to relentless light damage. What's shocking is that lutein and zeaxanthin are not interchangeable with other antioxidants like vitamin C or vitamin E because they occupy specific physical locations within eye tissues, positioning themselves precisely where light-induced oxidation occurs most intensely. This spatial precision explains why supplementation studies often fail when dietary fat is insufficient, because these compounds are fat-soluble, meaning without healthy fats, they pass through the body unabsorbed, never reaching the eye where they are needed most. Studies have demonstrated that consuming leafy greens alongside fats like olive oil or egg yolks can increase carotenoid absorption several-fold, effectively transforming the same meal from nutritionally passive to biologically protective. Even more fascinating is emerging research showing that higher macular pigment density is associated not only with reduced cataract risk, but with improved visual performance, better contrast sensitivity, reduced glare, and faster visual processing, suggesting these compounds enhance how the brain interprets visual information. This implies that leafy greens don't just help preserve vision for the future, they may subtly improve how clearly the world is seen today, long before disease ever appears. At a cellular level, lutein and zeaxanthin reduce inflammation, stabilize cell membranes, and protect mitochondrial function within eye cells, preventing the energy collapse that often precedes tissue degeneration. And unlike many nutrients, the body cannot synthesize these compounds, meaning every molecule present in the eye is a direct reflection of long-term dietary habits, a biological record of how consistently the eye has been protected. This is why populations with diets rich in vegetables, particularly dark leafy greens, consistently show lower rates of age-related eye diseases, even when controlling for genetics, smoking, and sun exposure. It also explains why cataracts are increasingly appearing earlier in life, as diets shift away from whole foods toward ultra-processed calories that provide energy but no optical defense. The lens does not care about calories, convenience, or taste preferences. It responds only to molecular protection. And when that protection is absent, transparency slowly gives way to opacity. Every serving of kale or spinach becomes more than a meal. It becomes a deposit into the eye's protective system, reinforcing a biological shield that weakens with age but strengthens with consistency. And the most powerful realization is this: cataracts do not suddenly appear because the eye fails. They emerge because protective compounds quietly disappear over time, leaving the lens exposed to decades of accumulated damage. When leafy greens are present in the diet, lutein and zeaxanthin accumulate, light is filtered, oxidative stress is reduced, and the lens retains its clarity longer than biology alone would allow. This transforms eye health from a passive outcome of aging into an active daily choice, one that begins not in the operating room but in the foods placed on a plate. Because in the end, vision is not just something we lose, it is something we either defend or neglect, one meal at a time. The most overlooked truth in nutrition is not what you eat, but what your body is actually able to absorb, because a nutrient that never enters your bloodstream might as well not exist. And nowhere is this more devastating than in the fight to protect vision. Millions of people consume foods labeled as healthy, believing they are safeguarding their eyes. Yet, research repeatedly shows that without proper absorption, critical nutrients pass straight through the digestive system unused, leaving the eye just as vulnerable as if those foods were never eaten at all. Lutein and zeaxanthin, the carotenoids most strongly associated with eye protection and reduced cataract risk, are fat-soluble molecules, meaning they depend entirely on dietary fat to cross the intestinal barrier and reach the tissues that desperately need them. Without fat, absorption rates can drop to nearly negligible levels, a fact confirmed in controlled feeding studies where participants consuming leafy greens without fat showed dramatically lower blood carotenoid levels compared to those eating the same greens with oils or eggs. This means a dry spinach salad, no matter how organic or expensive, may deliver only a fraction of its potential benefits, while the exact same spinach cooked with olive oil can become a powerful biological shield for the eyes. The science behind this is both simple and unsettling because the human intestine absorbs fat-soluble nutrients through micelles, tiny fat-based transport vehicles, and without enough fat present, these vehicles never form, leaving lutein and zeaxanthin stranded in the digestive tract. Researchers have shown that adding as little as 3 to 5 grams of fat to a meal can increase carotenoid absorption by several 100%, turning a nutritionally weak meal into one that actively feeds the retina and lens. Egg yolks, in particular, have been shown to dramatically enhance lutein absorption despite containing lower absolute amounts than leafy greens, because the fats in eggs are uniquely efficient at delivering carotenoids into circulation. This creates a shocking paradox, where a person eating salads all day may absorb less eye-protective nutrition than someone eating fewer vegetables but combining them strategically with fats. Even more striking is the fact that blood levels of lutein and zeaxanthin are not just markers of intake. They directly predict macular pigment density, meaning absorption determines whether these compounds actually end up embedded in eye tissue, where they can filter light and neutralize free radicals. Studies consistently show that people with higher circulating levels of these carotenoids experience reduced glare sensitivity, improved contrast vision, and lower rates of age-related eye disease, outcomes that do not occur when absorption is poor. Cooking methods also play a critical role because heat breaks down plant cell walls, releasing carotenoids that would otherwise remain trapped. And research has found that lightly cooking leafy greens increases bioavailability even when nutrient content appears unchanged. This is why populations consuming cooked greens with oils, rather than raw vegetables alone, often demonstrate better eye health outcomes despite similar dietary patterns on paper. What makes this especially urgent is that aging itself reduces digestive efficiency, meaning older adults absorb fewer fat-soluble nutrients even when intake remains the same, creating a silent nutritional deficit at the exact stage of life when eye protection is needed most. This helps explain why cataracts accelerate after middle age, not only due to cumulative oxidative stress, but because the body becomes less capable of absorbing the very compounds designed to counter that damage. Metabolic health further complicates the picture because insulin resistance and gut inflammation impair fat digestion and nutrient transport, reducing carotenoid uptake even in people who appear to eat well. This means absorption is not just about food choices, but about the entire metabolic environment in which those foods are consumed. Research has shown that individuals with higher body fat levels often have lower circulating carotenoids because these compounds become sequestered in adipose tissue instead of reaching the eyes, effectively hiding critical nutrients away from where they are needed most. This turns absorption into a competition between tissues, and without consistent intake paired with proper metabolic support, the eyes often lose that competition. The consequences of poor absorption are invisible at first, because the eye draws from existing reserves, but once those reserves decline, oxidative damage accelerates rapidly, and lens proteins begin to lose their clarity. This is why supplementation studies produce mixed results, because swallowing a capsule does not guarantee delivery, especially if taken without fat or in individuals with impaired digestion. The research is clear that consistency matters more than dose, because carotenoids accumulate slowly over time, meaning small, well-absorbed amounts taken daily outperform large, poorly absorbed doses taken sporadically. In long-term studies, people who consumed moderate amounts of lutein-rich foods with fats consistently showed better eye outcomes than those relying on high-dose supplements without dietary support. This reframes eye health as a daily biochemical ritual rather than a one-time intervention, where each properly absorbed meal reinforces the eye's defenses against light and oxidation. The lens does not respond to intentions or labels. It responds only to molecules that arrive intact and functional, capable of neutralizing free radicals before proteins are damaged. Absorption transforms nutrition from theory into action, from good intentions into physical protection. Every time leafy greens are paired with olive oil, avocado, nuts, or eggs, the body receives a signal to transport, deliver, and store eye-protective compounds where they matter most. And every time they are eaten without fat, that opportunity quietly slips away. This reality exposes why cataracts are not simply a failure of aging eyes, but often a failure of nutrient delivery over decades, where protection was available but never fully utilized. The difference between clouded vision and preserved clarity may not lie in exotic treatments or late-stage surgery, but in whether critical nutrients consistently cross the intestinal wall and reach the lens in time. Absorption is the final gatekeeper of eye health, the invisible factor that determines whether food becomes medicine or merely waste. Because in the end, the eye cannot be protected by what is eaten, only by what is absorbed, delivered, and retained, meal after meal, year after year, until clarity is either preserved or lost forever.